Hello students, today I am going to start with the first unit, that is solid state. As you know already that matter exists mainly in three states. The first one, solid state, liquid state and the gaseous state. So this year we are going to focus only on the solid state. And in solid state, as you know already, the constituent particles are regularly arranged. So very few of the characteristics of solid state you are knowing that. Consider one crystal, solid. Here the constituent particles are regularly arranged. So the solids have a definite shape. The properties of solids are they have a definite shape and they are rigid, they are incompressible, and internuclear distances are very small. That means the distance between two particles is very small. Internuclear distances are small. Whereas the intermolecular forces are very strong. The intermolecular forces between two particles, it is very strong. Intermolecular forces are strong. So these are the few properties of solids. Depending on the type of arrangement of the constituent particles, the solids are classified into two types. These solid substances, depending on the type of arrangement, the solids are classified into two types. One is crystalline solids and the second type, it is amorphous solids.
Examples of crystalline solids are sodium chloride, cesium chloride, copper, zinc, etc. And examples of amorphous solids are glass, plastic, starch, rubber, etc.
In crystalline solids, the constituent particles are regularly arranged. Here, the constituent particles means it may be the ions, or it may be the atoms, or it may be the molecules. So, in general we call it as the constituent particles. These are regularly arranged. That's why we say that, or let us see the difference between these two. So, as they have regularly arranged, they have a definite shape or definite geometry, we can say. They have a definite shape or they have a definite geometry. Whereas amorphous solids, this amorphous is derived from a Greek letter known as amorphous, means it is no form. Amorphous means it is no form. That means the constituent particles are not regularly arranged. So they have not a regular geometry. That means they have irregular shape. They have irregular shape or irregular geometry, we can say. And as I said, the particles are regularly arranged in a definite manner and it is going to extend throughout the space or crystal lattice, and it is going to repeat again and again. That's why we can say that these have long range order. They have long range and short range order. Short range order. Let me consider one crystalline solid here. Here the particles are like this. The same arrangement is there. It is going to extend in space. The same pattern is going to repeat it. It is repeated again and again. That's why we say that they have both long range order and short range order. But here only short range order is the same. Here to some extent we can see the orderly arrangement of patterns or orderly arrangement of constituent particles like this. To some extent we can see in amorphous solids, to some extent we can see the orderly arrangement, but after that again it is going to scatter like this. They have an irregular arrangement. That's why in amorphous solids we say that only they have short range order. They have short range order. And the third difference, they have sharp melting point. They have sharp melting point. Means it melts, the crystalline solids melts at a sharp temperature. It has a specific temperature. It melts at a specific temperature. If the melting point of a substance is 80 degrees Celsius, it melts exactly at 80. But here amorphous solids, it melts over a range. They melt over a range. For example, it is a 150 to 200 or 150 to 250 degrees Celsius. Over a range, the substances are going to melt. And next one, these crystalline solids, they are known as, or they are anisotropic in nature. This is a different term, anisotropic in nature, whereas amorphous, they are isotropic in nature. Isotropic in nature. Anisotropic means some physical properties like refractive index or conductivity. When you measure along different directions, we are getting different values. Let me consider, to explain this, let me consider one crystalline solid here. These are the particles. Let me consider one more type of particle here. Two types of particles are regularly arranged. So this is a crystalline solid. It is like this. Now I will consider one direction. Say this as a AB, and one more. If I consider this, say it is a CD. Consider this AB, we will find only one type of points or one type of particles. And if you consider this CD along this direction, we get different particles. That means the number of particles are also different and the type of particles are also different. That's why we will get different values for some physical properties like refractive index or conductivity, etc. But that's not the case in case of isotropic. All the physical properties, they have same values even if you measure along different directions. That's the meaning of this isotropic. They have same values but they have different values along different directions. That is the meaning of anisotropic. And one more thing, these crystalline solids, they are also known as true solids. These amorphous solids, they are also known as pseudo-solids. Pseudo-solids or supercooled liquids. These are also known as supercooled liquids or pseudo-solids. They are not true solids. For example, the glass panes fixed at windows or doors, they appear thicker at the bottom than at the top. It is because as a glass is an example of amorphous solid, but it has the tendency to flow very slowly. Like liquids, the amorphous solids have the tendency to flow very slowly. On changing temperature conditions, during day heating takes place and night again cooling takes place. Heating and cooling over this the temperature change or temperature conditions, the glass it melts slowly and flows down and collects at the bottom. That's why they appear thicker at the bottom than at the top. That's why we call these solids as pseudo-solids. They are not true solids, they are pseudo-solids. And one more thing, we can observe that the old buildings, window panes, they appear milky. This is again because of glass, I said it is an amorphous solid, but due to changing conditions or due to partial crystallization, it appears milky. Here, depending on the nature of arrangement, we have studied two types, that is the crystalline and amorphous solids. Now, these crystalline solids, again these are classified into four types. These crystalline solids, these are classified into four types depending on the nature of binding forces. We are classified into four types. One is ionic solids. Second type is covalent solids. Third one, molecular solids. And fourth one, metallic solids. This is depending on the nature of bonding forces. Crystalline solids are classified into four types. Let me consider the first one. It is ionic solids. Here, the constituent particles are cations and anions. Cations and anions. And these are held together by strong force. That is an ionic bond. They are held together by ionic bond, and these cations and anions are regularly arranged in space. Few properties of ionic solids: they are hard and they are brittle. They have high melting point. And they do not conduct electricity in solid state. Do not conduct electricity in solid state. Whereas because there is negligible movement of electrons, means there is no free electrons or ions. That's why they do not conduct electricity. But they can conduct electricity in molten state or in aqueous solution. For example, ionic solids, sodium chloride, cesium chloride, magnesium oxide, etc. So here the constituent particles are ions, positive and negatively charged ions. Next one, covalent solids. Here the constituent particles are atoms, and mostly these belongs to non-metals. These atoms belongs to non-metals. For example, covalent solids, it is a diamond, graphite, etc. Consider example of diamond. Diamond, it is allotropic form of carbon. Allotropic form of carbon. Here carbon is sp3 hybridized. Each carbon, it is tetrahedrally bonded to 4 other carbon atoms, and it is going to form a network. That's why these covalent solids are also known as atomic solids. Atomic solids or network solids. Network solids, because it is going to form a three-dimensional network. Last year we have studied the structure of diamond and graphite. Tetrahedrally is linked to 4 other carbons in space, forming a three-dimensional structure. So that's why these are also known as network solids. And these properties of these covalent solids, again they are hard. They are also hard, brittle, and have high melting point. They have high melting point. And they are insulators. Insulators, they do not conduct electricity. But graphite is an exception. Graphite, it is an exception because it conducts, it's a good conductor of electricity. Due to availability of free electrons, it conducts electricity. But usually these are insulators. Then the third one, it is molecular solids. Molecular solids. Again, there are 3 types. Here, polar, or consider first non-polar molecular solids. Non-polar molecular solids, polar molecular solids, and hydrogen bonded molecular solids. Molecular solids. Let me consider the first one, non-polar molecular solids. Here, the constituent particles are atoms. For example, solid argon, solid neon, etc. That means they are atoms. Or it may be molecules. Like hydrogen, solid hydrogen, solid nitrogen. The constituent particles may be molecules like hydrogen, oxygen, nitrogen, helium. It may be molecules. Here in non-polar molecules, they are not having any charge. So because of the absence of charge, they are held together by weak van der Waals forces, or they are also known as London forces. Weak van der Waals force or dispersion force or by London forces. So because of the absence of, there is no polarity. That's why these are called as non-polar molecular solids. The next one, the polar molecular solids. As the name suggests, polar means, for example, here it is polar molecular solids. It is solid HCl, solid sulfur dioxide, etc. These molecules have polarity, means there is a difference in the electronegativity. This is a partially positive and this is partially negative. There are 2 poles, partial positive and partial negative. That's why these are known as polar molecular solids, and they are held together by strong force. And next one, hydrogen bonded molecular solids. Here these are the molecules in which they are bonded by covalent bonds means the hydrogen is bonded to more electronegative elements. More electronegative elements like nitrogen, oxygen or fluorine. So that type of bonds are known as hydrogen bonded molecular solids. So these molecular solids, they are soft. They are quite soft. The properties are they are quite soft and they have low melting points. They have low melting points. Now the last one, that is metallic solids. Metallic solids. Here the constituent elements are atoms belonging to the same element. For example, consider copper metal. Copper metal, it is a metallic solid. Here the atoms of copper are linked by metallic bond. Actually what happens in a metal atom, it consists of two constituents. One is free electrons or valence electrons. Valence electrons and the residual positively charged residues. The positively charged residues. These are known as kernels. There is a bond between the valence electrons and the kernels, and these are linked by metallic bond. Example, copper metal. And these are properties, they are malleable and ductile. They are malleable and ductile, and even though these metallic solids are solid state, they conduct electricity because of the availability of free electrons. They conduct electricity due to availability of free electrons. So here we have studied two types of solids. One is crystalline solids and amorphous solids. Again, these crystalline solids are classified into four types: ionic, covalent, molecular and metallic solids.